We learned that definite integrals, when you integrate a function from a to b, is calculated by first finding the antiderivative and plugging in the endpoints like this. So you plug in b first and then a next, and you subtract them. And this thing is what we call the fundamental theorem of calculus. And the reason this equality is a theorem is because the left side is defined as the area under the curve, and the right side is antiderivative, and this equation, this equality, is something that's not so trivial at the beginning. People wouldn't think that the antiderivative would have anything to do with the area under the curve, and that's why it's called a theorem. Yeah, but it's true. Yeah, so if you want net area under the curve, then that's equal to this antiderivative evaluated at the endpoints, and you subtract them. Okay. Right. Now what I want to do is to demonstrate the above as a calculation. How do you actually use this FTC, Fundamental Theorem of Calculus, FTC, to evaluate this? Well, you just use the antiderivative and you plug it in. Okay. So let's do this one. First, using the power rule, integral of x squared dx is you add 1 to the exponent, so that's 3, and you put the reciprocal in front, 1/3 plus c. And also integral of x dx, well, that's integral of x to the first power dx. So if you add 1 to the exponent, that's x squared, and you put the 1/2, the reciprocal in front. So these are the integrals, so we know what the antiderivative is. Antiderivative would be 1/3 x cubed coming from the first one, and then minus 3 times the integral of x is 1/2 x squared. And then you have to evaluate this at 2 and -1. Let's simplify this before we actually evaluate. So it's 1/3 x cubed minus 3/2 x squared, and you have to evaluate at 2 and -1, which means first you have to plug in 2, and then subtract. And it's very important that when you subtract, you put the parentheses, because or else it's so easy to make a sign mistake. Okay, so make sure you put this parenthesis, and 1/3. This time -1 is plugged instead of x, so instead of x I put -1. It's also important to put this parenthesis. Okay, when you plug in values, please use parentheses like this. Okay, so 3/2, -1 squared. Okay, 2 cubed is 8, so you get 8/3. And then 2 squared is 4. 4 times 3 is 12, so you get 12/2. Minus -1 cubed is still -1, so this is -1/3. -1 squared is +1, so you get -3/2. Now that gives you 8/3 minus 12/2 is 6. Negative is +1/3, and then negative again is +3/2. And I like these two because they have common denominators. So I have 8 plus 1/3 minus 6 plus 3/2, and then this is 9/3, that's 3, right? So you have 3 minus 6 plus 3/2. We're almost there. 3 minus 6 is -3, and 3/2 is 3/2. And let's make common denominators. Another way to do it would be to make 3/2 as 1.5, but I like fractions better. Okay, so you have -6/2 plus 3/2. I made -3 as -6/2, so now they have common denominators, and -3/2 would be the answer. Okay, so the meaning of this, what's the meaning of this? Well, if you draw the graph of x squared minus 3x, it's like this. At 0 and 3 are the two zeros of this function. So if you draw this graph, this is the graph that you have. And that definite integral has the meaning of integrating from -1 up till 2. So it's this shaded area between the curve and the x-axis, and it's called the net area or signed area because when the curve is above the x-axis, it's considered as a positive number, and if it's below the x-axis, it's considered as a negative number. So it's this area minus that area, and just by the picture you kind of see that this area is more, right? So because you have something bigger subtracted from positive, the answer should end up with -3/2. So it kind of makes sense, okay? Now let's just do one more example just to make sure that we know what we're doing, okay? Now here's the next question. You have to be careful here. Although integrals, when you have some function and another function, you can split them like integral of fx plus integral of g of x. Such is not permitted for products. When you have two things multiplied, it's no longer true that it's the integral of these separately. So that's not true. You can't do that. And the reason for that is because antiderivatives, by the fundamental theorem of calculus, this definite integral uses the antiderivatives, but antiderivatives are from derivatives. And for derivatives, if you have f times g, if you differentiate, you get this very complicated thing called product rule, right? So because differentiation doesn't work that way with the products, it's not so simple. The integral of products is also not so simple. It's actually very complicated. Alright, so for now, we're not going to learn how to handle the products of the integral of products. Later in the Calculus 2, you're going to learn this as the integration by parts. But you're going to worry that later. For this class, whenever you see a product, you first want to distribute them to make sure that you don't have a product. So we will first rewrite this as x to the 1/2 times 5x plus x to the 1/2 times 6. And see, x itself is x to the first power, and since x are same base, the exponents add up, right? So you end up with integral from 0 to 2 of 5 times x to the 1 plus 1/2 is 3/2, and then plus 6 times x to the 1/2 dx. Now we can use the power rule to integrate each individual ones. This you add 1, so that's adding 1 gives you 5/2, and put the reciprocal in front. That's the power rule, right? You put the reciprocal in front. Same thing here. You add 1. 1 plus 1/2 is 3/2. You put the reciprocal in front. There's still 6 and 5 there. Luckily for this, 5 cancels, and 6 divided by 3 is 2. 2 times 2 is 4. So you have 2 times x to the 5/2 plus 4x to the 3/2. Now, since this is not an indefinite integral, it's the definite integral, you don't put plus c. For definite integrals, you never put plus c, okay? And instead, you put the endpoints 0 and 2. So you have to plug in 2. So you get 2 times 2 to the 5/2 plus 4 times 2 to the 3/2, and then minus and then you plug in 0. 2 times 0 to 5 over 2 plus 4 times 0 to 3 over 2, but 0 to positive powers are 0, right? So this is 0, and you just get that, okay? Now, when you simplify your answer, it's good to go back to square root, okay? So let's see. If you have 2 to the 5 over 2, that's 2 to the 4 over 2 times 2 to the 1/2, right? I split out the 1/2 because 5 over 2 is 1 plus 4 divided by 2. Right? 4 plus 1 is 5, right? I split the 1/2 out because I know that that's square root of 2. And 2 to the 4 over 2, that's just 2, right? So that's 2 square root of 2, which is 4 radical 2, okay? On the other hand, you have 2 to the 3 over 2. You can do the same thing. This is 2 to the first power times 2 to the 1/2 power, which is 2 times radical 2. Okay, so using those, we will simplify the answer. So the first one is 2 times 4 radical 2 plus 4 times, the second was 2 radical 2. Oh, okay, so they both give you 8 radical 2 plus 8 radical 2, adding them. And the reason, these two are equal just by coincidence. Usually they will be different numbers, but somehow by coincidence they happen to be the same. All we want to make use of is really the fact that radical 2, these are like terms because they have the same radical 2. So 8 plus 8 gives you 16. So the final answer will be 16 radical 2. That's the answer.